All right, so we're going to look at the surface area of a cone here, and a cone is first off pretty obvious. It's made up of a circle, so we've got our circle on the top. Now, a couple things about cones that are worth understanding is we've got a couple of different measurements here. We have right here the height of the cone being that inside height, and we have the side length of the cone. So when we're dealing with this particular shape, what it turns out we have is first off, we've got our circle. That's pretty obvious, circle at the top of the cone. But otherwise, what do we do to actually make this other shape? And what you'll find is if you take a circle and you take a chunk out of it to basically make what I like to call a Pac-Man, and then you bring these two sides right here together, it's going to give you a cone. And this right here, the length is going to be the same of this piece. Basically, the mouth of the Pac-Man is going to be the same size as this length right here. And so these things are related. We basically have a radius here that is the length of that overall. So what we're actually going to do, first off, let's go back and we've got our r squared pi because we have the circle. And then over here, all we really have to do to get the surface area to get this Pac-Man shape is we're going to go ahead and use its radius times pi times the length. And that'll give us the area of this Pac-Man-ish figure. And so it's a pretty simple formula: radius squared pi, and because this is surface area, we're going to add the radius times pi times the length, and this is for the surface area of a cone. So, for example, if right here, and we do want to be careful if we had a circle here with a radius of 2, and let's just say we had a length of about 5, so the radius is 2 and the length is 5, we would just go ahead and plug that in. Radius, so radius is 2 squared times pi plus 2 times pi times the length, which in this case we can go back and say we know the length is 5. So over here we would have 4 pi plus 2 times 5. 2 times 5 would be 10 pi. And so we've got that. Add those together, we end up with 14 pi. If you multiply that out, you get about somewhere around 45 would be what you get if you multiplied it times 3.14. And so that's all you need to do. We don't end up using the height at all right here. We only use that when we're getting area, and when we're getting volume. We don't use it when we're getting surface area. All right, so I've got another cone here, and I want to show you something that's a really important concept with cones, which is the shape that is made right here between our radius, our height, and our length, and our side length there. Let me draw that a little clearer for you, side length there. And so what you may notice, and if you're paying attention looking in here, you may see that what we have right here is a right triangle. So what this means is for a cone, the radius squared plus the height squared is going to equal the length squared. And that basically works out into Pythagorean Theorem because we know that this triangle is a right triangle because the height tells us how far it is from the cone down, from the center of the cone down to the bottom. And so we can use this, for example, if we come back up here and we say, okay, this radius is 3, this height right here is 4, well, what's our length going to be? Well, we can go ahead and plug this into the Pythagorean Theorem. 3 squared plus 4 squared equals length squared. And in this example, we have 9 plus 16. So 9 plus 16 equals our length squared. So 9 plus 16 is 25. And 25 equals our length squared, meaning that we get the square root of both sides of that, and our length is 5. And so we can use this in order to, if we know the radius and the length, we can get the height. If we know the radius and the height, we can get the length. If we know the length and the height, we can get the radius, because all those things have to function in proportion.